So now, before I do this one, have either of you seen this activity before? No. All right. So since I know the answer, I don't think that it's fair for me to be the one uh, to to participate. So I'm going to give the two of you about maybe like 5 minutes or so. You can draw on the screen, talk about it, whatever, for 5 or so minutes, and then I'll give you some insight into the problem at that point.
So what do you think, Inda?
I think we add even number all the time. Do you think the same thing?
I mean, it seems like if they're adding in one dot per row, but also adding in, or they're adding in one row and also one dot per each column, then I'm getting that the pattern is going to be, there's going to be 20, there's going to be 20 rows by the 20th step. They'll have 20 rows, but they'll have 21 dots in each row.
Yeah.
Okay. So that would be math 420. Is that 420? 20 times 21.
Oh, it will be 21 times 21, isn't it?
Yeah. So I'm thinking there's going to be 420 dots total in the 20th step.
Okay. I'm still doing it.
Okay.
Yeah, I agree with you.
Okay.
All right. So let me ask a different question then. Can you give a formula or a formula for any
Step.
yeah, any step, yeah.
Do you
guess
mean how many dots added, or
The formula for the number of dots at any step? So like if I said
n plus 1 times n?
Okay, all right,
I
yes.
agree.
So now let me ask you this. How do I say this? Do you think that 420 is a unique answer? Or can you think of a different way to look at the problem? So I'm going to give you a couple of minutes to think about the problem again and see if you can come up with a different answer other than 420, whether it's using a different formula or that you can come up with given the pattern of only the first 3 steps, or some other reasoning that you come up with. So I'll give you a couple of minutes to think about that one now.
We can use a recursive formula.
Yeah.
But the end result will be the same, but the way we got there using recursive formula, is that what you have in mind?
Yeah, I agree. And it's only, I mean, the formula we have is only off by division by 2 if you're adding up the first n consecutive, adding up n consecutive positive integers. And it's only because it's off by 2 because we start off with 2
2.
dots to begin with.
Yeah.
So what would your here, I can write down, what would your recursive formula look like then?
The first number would be 2.
Mm-hmm.
And then the second, wait, let me write that down, what I have in mind.
You're thinking about recursive formulas in what a sub n is equal to what previous step or steps?
Yeah.
Okay.
Well, I'm going to give you while you're thinking about that, or maybe not. If I'm going to tell you that you got the answer, the textbook answer correct, but if you let n be the step number, and so like 1, 2, 3, and then these are the dots. Well, let's say that you actually look at this and you do something like oh yeah, like let's say you see, well, that increased by 4, right? Let's say you saw that one increase by like another 6, but what if you assume that like, because it didn't say that the next one only goes up by 7. Because it didn't say, right? So you only had to assume that all it said is that at each step more dots are added, and that the number added at each step is more than the number added in the previous step. But it didn't actually say that it had to
The
be
pattern does
anything.
continue
But
indefinitely.
it said the pattern continues infinitely. So the pattern should be like, if you have that kind of row and columns, then the pattern should still stay the same, right? That's what I get from the problem
Well,
there.
but the question though was
Just more
yeah,
than the previous.
the question was about the number of dots though. So that's like the question was about the number of dots and not about describing the pattern. That's the only
Mm.
catch here. So like so if somebody saw a different pattern, then like if somebody saw a different pattern, then who's to say that they might be wrong?
Yeah.
So I mean, if the pattern I saw in the dots was that, hey, like, well, it just I have to. The pattern is like if you look at the pattern in the numbers, that all the pattern, instead of looking at the pictures, the pattern in the actual numbers, that the pattern is that they're increasing by at least one more than the previous one. Then that's different than maybe looking at the pattern in the pictures of the formation of what the pictures would look like themselves. So that's just a thought, and not like a like a end all thought, but it's one of them. And so if you do that, then that would give you the lowest number possible of dots that you could get, which ends up being 220 267 dots. Now, I'm not going to tell you everything about this. I don't want to actually have it be too big of a surprise, but let's say that you do something like like you look at the ratios of the dots. So let's say that this was multiplied by 3 and then by what is it, by let's say you do 2 and then you multiply the next one by 3. Let's say the pattern ended up being like multiply by 3, multiply by 2, multiply by 3, multiply by 2, right? Because there's nothing that says that couldn't be the pattern also. Then this one would actually be adding 36, and then by the time you get to the 20th step, you would have 6,466,176 dots. So that's another way to look at it as well. So all right, I'll tell you though that this is one of those where the original problem was given on a national standardized test, and the answer was expected to be 420, but because of the fact that there were it wasn't clear exactly what was going on, that only 6% of students got the problem correct. But at the same time, I think that shows in a way the importance of inquiry-based learning, because that can't be measured on a standardized test where you put down one correct answer, and then if a student was thinking about the problem a different way that you weren't maybe thinking about when you wrote the question, then you're probably going to mark the student wrong. Although if a lot of students actually got a problem incorrect, you might actually go back and say a lot of students got incorrect, and then you start investigating the student reasoning. But maybe the lesson here is that you should investigate the reasoning before it gets to the point that this would happen. So that's just a thought. All right. Now let me, I hope you at least enjoyed that. And actually, I'll show you. I can share this paper with you at the end, but it actually shows at least there are several ways that that this paper shows to do the problem. So one of the answers end up being 1,048,614 even. So that's my whole point, is sometimes, like even on my problems that I give my classes, one thing I'll do is say, can you do the problem a different way? Or can you show me a different solution? Or can you get a different answer? Or how would that look? So a lot of my problems definitely don't have one correct answer. And even if it does have like a single, say, number that's correct, I know that there's lots and lots and lots of ways to get to the same answer. And so any of those are okay. And I think that having the students like think about the different ways is helpful. So now you can just say this out loud, but since there's just two of you, but I want you to think of a class or just a topic within a class that you think IBL would be the most helpful for, and why. So that could be something like a topic where you know that's difficult for students and you want them to get a deeper mathematical understanding of it, or a topic where you just don't feel like you've ever been able to get it just right with the students and you're willing to try a new technique on it, whatever it might be. What are your thoughts? Inda, do you want to go first?
This reminded me of whenever we have to deal with rational expressions, students tend to forget that they have to make sure to eliminate or to exclude whatever values that will make the denominator 0. And I remember giving them a problem with the answer. And I said, what do you think about the answer? Is this correct or incorrect? And it should be incorrect, because that number should be the what I call by forbidden numbers, because you cannot include that number as part of the solution because it will make the denominator 0. But the students cannot really see them, because when you simplify the expression, that value disappears. So they don't think about that anymore. And I think students have to be reminded all the time about those. So that's the thing that I remember. And then also when we deal with a square root expression, we have to make sure to check whether our answer are not what makes the square root a negative values. And logarithm as well. Yeah, those kind of type of things that students always miss. So I always give them an answer of a problem and ask them whether the answers are correct or not, and why they think that should be correct or incorrect.
Thank you, Inda. Mike, how about you?
That last example made me think immediately of the difference, having students figure out the difference between linear, exponential, and quadratic modeling problems, where they're just given a set of data and they're asked which model would be most appropriate, and having them think through the relationships between consecutive terms is immediately what I thought of with that last problem.
So the difference between consecutive terms, yeah.
Because most students think very with linear functions primarily, and maybe to a lesser extent quadratic functions, but getting students to understand the difference between linear, quadratic, and then also exponential is a challenge sometimes.
Oh yeah, that's a good point, Mark. Because I remember I gave the students a problem, not a problem. I gave them one quadratic equations, and then I asked them to say 5 things about the properties of that equation. And I said, there is no slope. And I was like, why are you talking about the slope? We are talking about something that is not linear. Yeah, so yeah, that's a good point.
Well, like most students, whenever they're, I mean, I'm teaching college algebra more often than any other course. And the techniques that students use are primarily for linear equations.
Mhm.
And it's just vastly different if they understand the difference between the types of equations, types of functions, types of relationships between just sequences of numbers would even help.
Yeah. Mhm.
So I think that I feel like the overarching issue is like just types of functions and domain and range. So then I think that we can why don't we start with that issue then, and so let me like save this. All right, let me clear this. And so oh, I don't know what has happened because I want it to clear. So a lot of these things are that both of you mentioned are things that are very good strategies for converting a standard question to an inquiry based question, like rephrasing solving a problem as a question, or like you mentioned in the state 5 properties about the function instead of just like graph this function, or what is the domain and range, like just tell the student to state 5 properties and make them think about what the function is and what it would look like. And then Mike, you talked about the pattern recognition, and that's an important thing also. And maybe asking for counter examples, or what would happen if where I had one that would be a good like counter example, but like maybe show why the probability of an event can't be greater than 1, or like things like that could be good practice. Now, one thing I will say, I put these 2 documents here because last year the MichMATYC had a Midwest meetup where we talked about the group work and assessment online, and people came up with some of these suggestions for ideas for problems. And so a lot of these are things that you may have thought of, like asking students, like, why did you find a certain problem difficult, or using the open-ended properties. And maybe you were being too nice because somebody's suggestion was to list 10 properties of a function. So maybe you up it from 5 to 10, who knows? But yeah, so
with that 5 students, one student managed to make 1 property into 5. So what was that? The leading coefficient is 3. the leading term is 3x squared. That so it's just saying the same thing. Nothing about the intercepts, nothing about so just one.
Oh
That-
boy.
So if I make it 10, then they would say the same thing 10 times, just using different numbers, different words.
Well, I mean, I think that that's actually, in a way, that's, I guess, not too bad, because at least then they know some of the vocabulary, and then that's a start.
Yeah.
But yes, I know that I mentioned already solving using a different technique, and then I'll say that the other Midwest group from last year, we talked about writing some of these questions, and this was more of a set that was done by a topic rather than by just general technique. So one of them here was to just come up with an example of a function in real life. But I want to say, before we talk about, like, specifically, or go out to investigate hands-on for a little while, like some like maybe solutions to the rational uh, um, like functions and the square root functions and the domain, and making sure that students check their solutions to square root equations and rational equations, then there are some sources of Ibl materials. And so the first one, and I'll make sure that I show you where everything is at, and what's available, because this is where I think the best part of the presentation is probably at. But there's, under the Academy of Inquiry-Based Learning website, there's resources, and so there's different textbooks where you might find questions in, or materials, or links. And so I do want you to take a look at those. But then the Aibl Dropbox folder, this one is from the workshop that I attended, but I know that they did share. Actually, this might actually not be from that workshop, but this one is from the Michigan Aibl. Yeah, and so here there will be, let's see, where would, pre-calculus would probably have our material that we're looking for, and somewhere in here. And then the Ibl Resource Spreadsheet, this I did get from the workshop I attended, but I think that I found helpful, but it had a lot of the same links as on the Aibl website. And then what I also found, though, is that having everything organized by topic was helpful. And so that is one thing that I would recommend, that when you go looking for these resources, if you actually find one that you think would be helpful, then maybe just like, but not for the topic that you're working on right now, then just put it off to the side. But you can see that here's pre-calculus resources, and then here's just some general inquiry techniques. So I am, to make it a little bit sort of more helpful and maybe not so overwhelming at first. Maybe I thought that we could just perhaps start by just how about creating a document of our own for this session, and if you see something specifically relating to the topics that we want to maybe tackle today, then we can put it in there collectively. So this is the workshop part of the workshop, where it's the hands-on. How are we going to deal with rational equations and square root equations? Are both of you okay with those being our topic of focus? Okay, so this is going to be our ideas for IBL methods for rational equations and square root equations. And so if you I'll share this right now. Actually, I'll put it in the link in the chat, and then we're doing this all as we go. I'm doing this as we go because I didn't know what the topic would be that we would want to talk about. So let me put it in the chat, and then let me say, how about in I can stop. How about I stop sharing my screen, but then for the next, say, 20 minutes until about 3:40, we can like add to that document and take a look and at whatever we find, and on those links. Oh, do you need all of those links shared again? Here, you know what? I'll put all the links that were in that presentation all in there, and then that way you can you see them in there? Hopefully, and
I can see them on the presentation you shared.
but not in the Google Doc.
I can see them.
Okay. All right. Good. So then, thank you. So then, does that seem reasonable? Like 20 minutes to poke around and look, and then we'll like record what we find in there, and then we can share out of why we put what we did in there, and why we think it could be a helpful resource for teaching either rational equations or square root equations.
Okay.
All right, so I'm going to actually I'll pause the recording and mute myself so that everyone can concentrate, and then feel free to get up and stretch, and then in around 3:40 or so, 20 minutes, we'll compare notes recording. But I figure I might as well share my screen again so that it will be in the recording. So all right, let's go ahead, and if we want to maybe go through and we can all maybe explain why we've chose something maybe that might help in terms of like adding a little extra value. So we can just start from the top. So I know that I added all the stuff in here at the beginning of things that were in the presentation slides, but let's see. So whoever like added which one, feel free to speak to your item that you added, but have students visualize via graphing a rational function. Who added that one?
That was me.
Oh, I almost didn't write anything because I was distracted by whatever you wrote, so I kept looking at those things.
Oh no.
No, I'm okay, but yeah, most of them are similar, so I'm good.
So go ahead, Mike.
So that one, I just wanted to have students just know the difference of what the graphs might look like for a square root function or a rational function. Because according to, for my classes, it's the first time they've seen the graph of a rational function or a square root function, period. So just knowing the behavior of the graph. So asking the students to understand what values can they actually input into the function is important for the domain. So I thought, have students look at the graph, and then what else did I put in? Yeah, students create their own table of values. They ask them to use values that are very close to the value that would make the denominator 0. That way they can see what the behavior of the graph would be when they get really close to the undefined where x equals c, and just study the graph basically.
So
I focused on rational functions, I guess.
So I did something interesting, and we'll see how it works out, because my students are actually turning in the assignment like this upcoming weekend, but I'm having my students actually create a because we're talking about piecewise functions, and I find out that that's one of the areas where the students really struggle with domain. And so I had them create a Desmos artwork using just any functions that we've talked about in class. So I really am wondering if, well, now I'm having the idea that if it ends up being a good idea, that I might have them do the same thing later on in the semester, but maybe require them to only use rational functions, or they have to use so many rational functions in the graph of whatever they want to draw. So I like that idea of having the students actually do the drawing. And actually I was going to show the one from my class the other day, but like I'm refreshing the page, and it is not actually for some reason letting me show it. So all right, how about the next one? Mike, was that yours?
So that one's mine still. So this one, I looked through the IBL stuff from Liz West, and she has some really good questions. So I found this one where it's really having the students look at why is the domain important for a function. So she had this problem where students are given an example where it's in words. So it's a number of gallons that the students would need for painting, and they have to describe they have to give examples of input values, but they also have to give the domain of the function and also describe the range as well. Well, I thought, okay, you can maybe something that can be extended upon that would be students can create their own function in words, not with mathematical symbols or anything, but they come up with a function in their own words, and they have to figure out what the domain would be for their function. or ask someone like another student what the domain would be.
Yeah, I like that idea, and I like that one. So so you found a lot of good things in Liz West book, Mike.
Yeah. So it mostly is from chapter 2, where she talks a lot about domain and range of a function. So what else did I put down? Oh, another idea would be give students just a variety of different functions, just the functions, not the graphs, just the functions, and say which functions are square root functions, which ones are rational functions, and then compare and contrast those functions with functions that they might be more familiar with, that they would recognize as linear functions or quadratic or polynomial. But they would be able to compare and contrast why is a square root function the way it is, or a rational function the way it is.
Yeah. Oh, go ahead,
But
Mike.
I was going to talk about the next example. The
Oh,
next,
yeah.
this is from Liz West also. Like I said, it might dive too much into calculus or pre-calculus, but having the students understand the difference between the function in number 1 and the function number 2, even though even though the function number 1 simplifies, having the domain stated is extremely important, and I think that's important for students to understand.
Yeah, I agree.
Even
And
though the graphing calculator will not actually show them a difference, having the students understand the difference between those two functions is vastly important.
well, and I think that like that's the issue, that even in Desmos they don't have the discontinuities in there correctly. But I will say that your handy TI-83 and TI-84, if you set the pixel settings correctly and zoom in enough, you can get the little discontinuity to show, but not on Desmos still, which is a bit unfortunate, I guess. But it may be, though, I do know that their general philosophy, though, is that the student should have some responsibility in realizing that there's different types of discontinuities. I was going to mention that I've been using the clicker questions in class this semester, and so I just go to the clicker questions, and then I like put up a poll in Zoom, and then have them enter A, B, C, or D, and then I sort of know right away which students have needed more help on certain questions or not. But they have some for, let's see, the rational functions even. So if we're talking about domain and range of these, then let's see. Yeah. So which of the following is a graph for this, or which of the following represents this graph? Now, it does say no calculators allowed. So like some of these, with that regard, I have not used all of them, but this is still a good source of questions, even if like some of them a couple of them I thought were so good that I gave them as homework, but I said explain why the wrong answers couldn't have been the correct ones. And that was a different way of looking at the multiple choice questions, not necessarily asking them which one was the right answer, but explaining why the wrong ones were incorrect. So it's another way of looking at these clicker questions. And then I'll honestly say that if you, as a side note, it's off of the specific topic that we were talking about, but the differential equation problems are actually really, really good. In my differential equation class seemed to love them. Like I did a whole class yesterday that was, we did clicker questions the entire class, because it was a lesson where it was questions about modeling linear differential equations, and so I wanted them to have examples of like how to set up the differential equation. So it was, here's this word problem, which of these would be model the situation, and so you can't really like look that up anywhere. You have to know what the problem is asking. So I like those types of problems. And then this one I added, it is Maria Anderson's contemporary algebra collection, but I've used a few of these in my classes from the collection already, but they're uh, fairly interesting, and I, especially when I'm talking about the piecewise functions this semester, it was helpful, and it also was helpful to give these real life examples in this case, because I realized that it helped the students see like, oh well, we're talking about the price of Spotify or the price of this fog bugs program, and so the price can't go below zero. So they realize that drawing the graph below like beyond certain x values didn't quite make sense. And then Maria Anderson has a course on Elmi education that is an expanded version of the contemporary algebra collection, where there's some more real world examples like that, contemporary examples for every topic in algebra. So let's see. How about this next one? Who added that one? And was that you? About the incorrect steps to a problem?
Yeah. So I asked students to solve one problem that they need to look problems, and then they try to solve it, but they have to make sure that their solutions are incorrect. So they have to have like wrong steps or something, and then they have to give it to the other group or the other students to check what kind of mistake that they made. And
Yep.
I was hoping that by that kind of activity, the students can check their own work before they submit their work, so they can find if they make mistake, because sometimes they cannot see like how to check their own work. So by checking somebody else, then probably they can look at theirs as well.
Yeah, I like that idea. I was going to say this one here. I don't know if you've have either of you heard of this one, Mike, or into this. Have you seen this file of Dictionary of Mathematical Terms? So I'll say that I absolutely love it, because it was a dictionary designed specifically for 2-year college students. And so when you go down here, like it will give it's definitely not the language that's used in the Oxford Dictionary of Mathematics, like this little like blue one I've had forever, but it's written in understandable terms that I think that students at the 2-year college can understand. And so I will have students go into the dictionary here and look up words and explain the definitions to each other as a way of increasing their understanding. So if you are looking for, I wonder actually what it says about square root if it's what it says about square roots even, because this is, where would it can't be that much farther, right? Because we're at S, Q, S, T, S. Well, I guess, well,
Page
I
136.
what?
136.
Oh, I scrolled too far. I knew it. There we go. So 136. I don't think that is. Where is that?
The document's 136.
Oh, oh, thank you, Mike. That's helpful. All right. So there it is. So I do think that this is helpful for students to realize that when we're talking about square roots, it could be we're talking a type of radical, and or people might just say root sometimes, and this is all very helpful, I think, for students. So I have them definitely look at looking up the words to help them. And that all goes back to what I was saying earlier, that for students who may not have come into your classes, say, with the same high school background or other preparation, having this as a tool like helps put those students on a more level and equitable playing field, that like no one has to worry about not knowing the word now, because it's okay for everyone to go and look it up if they need to. So I try to get that through to the students. It's okay if you don't know the word or don't know something, but you can look it up, and we all can look up a word that might not be familiar to us. And then I put down some of these OER resources for college algebra and pre-calculus, because especially the Yoshiwara books that they have. Actually, this one is the one that is, this is also one of their books, but it has a like it has, if you go, oh, it's link after link after link, but they do have a activities workbook for their modeling functions and graphs book that might actually help with finding ideas for IBL method. So an activities workbook right here with classroom activities for each section of their book. And then I put some, why does it say plus plus plus? I don't know why it says that, but then I also put some sort of links here to games and applets that I found for these sort of topics of rational expressions, rational equations, and radicals in the past. So I guess that's it. So what do you think, Mike and Enda? Maybe do you want to say one thing each, just to wrap up, of like one thing that you felt was something that's a good idea from this list that we made today, that you definitely want to go back and try out or investigate further?
Yeah, I'm going to try to practice some of the things that we have here next week on my classes. So let's see what happened there.
Oh yes, yes, definitely. Let me know what worked and what didn't.
Yeah.
I would love to hear that. How about you, Mike?
Yeah, I just need to go through the resources at the very top of the document and just explore some.
Yeah,
Because
in
I just looked at Liz West primarily, but I know there's others.
yeah, and that's my thought. Like that's why my whole sabbatical plan was supposed to be like converting the one course to IBL methods, because it's not something that can be done overnight, and you just have to like look at one little small topic at a time and go step by step and piece by piece. And so in any case, like I hope that that you found the at least having a starting point for where to look to be helpful, because I don't think that it's easy to find all of these resources because there's all over.
What if the students' gap are too big? Like half of them are quite good, but the other half was really behind. How do we bridge them? Because it happened to usually my classes are like that. So
Yeah,
some of them are not going to be able to keep up, and no matter how slow we are working on, and then we cannot move forward because we end up like trying to explain the things to the one that is really behind.
Yeah, I think that like one of the things that is always the big issue with like that comes up when working with IBL is how do I still like cover all the content when I want to use some of the more of the in-class time for the inquiry and giving them a chance to collaborate with each other and ask questions. But I found that the when like one thing, like I feel like the mastery learning has really helped, like giving the students unlimited attempts to get 100%, but otherwise it's a 0 if they don't get to 100%. Because what will happen, I found that a lot of students, the reason why they were struggling at first was because they 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 were they were behind. But then when I started doing this method, I told them, well, you know what, like if you like if I require them to do the get 100% from the very first assignment, then either they catch up really quickly, or else they decide they really are so far behind that it's not the right class for them, and they drop down to a lower class. And so I try to like tell them, like it's okay if you're behind, but you need to you need to work more outside of class, because you're not going to be get an exception from that 100% rule. And so I want you to do the tutoring and do this and do that. And then once they realize that they can be successful and get that 100%, I don't feel like I have as like as many students who are like are as far behind as when they started the semester. So and that's why I kind of alluded to the fact earlier, I guess, that a lot of people who use IBL in their classes also use the mastery based learning, because I think that there's not really a good way to do this otherwise, because you want students to have that time to think about how to do the problems. And so in order to give them that time, you have to wait until they get it, I guess. So I saw that's what I do, I guess. It's just wait. And if it takes them like 8 weeks, it takes them 8 weeks. If it takes them 2 weeks, it takes them 2 weeks. But I'm still moving along, like talking about the stuff in class. But like I will wait for them to get that 100%. So yeah. Do you have any closing thoughts, Mike?
No, I found everything wonderful. So thank you for sharing with us on IBL. I didn't realize that I was doing a lot of IBL already.
Yeah.
And it was just a small part of the umbrella that I was doing though. So I can actually definitely expand on that though.
Yep.
We didn't realize there's a name on that.
Yeah, and I think that was the I think that's the key, is that IBL sounds like it's a like like this new thing or different thing, but it's really like you take something you're already doing and make a few tweaks and a few more tweaks the next semester and add another activity on a different topic, and eventually it's all there. And like I said, I didn't learn all of this except for through going through that intensive like week-long workshop. And when I say intensive, it was like started at like 8 a.m. and then we went till 5 p.m. every day for a week, and then went out to dinner, and then had homework to do for the next day's session. So it was really one of these things where I appreciate everything that I learned from AIBL, and I would say always start there, because they're the group that knows the most and has all the links that you would need, and will help if you need it. But if you really can't find something, you can ask me too, because I'm sure that I have a link tucked away somewhere too. So let me stop the recording though.